Hello, this is Peter Larsen from Loudsoft. I want to show you some of the key features of FINEMotor. Starting with the voice coil, we can use round wires up to from 1 to 10 layers. We can use aluminium or copper clad aluminium, and we can even use edge-wound wire or flat wire. Let's start with a round wire in 2 layers and a DCR of 3 ohms. Now going to the magnet system, we have a selection of different grades, standard grades from China. We choose Y25 ferrite and one of the sizes here. We'll start with this standard size. Now we have here a selection of different designs that fit what we have input here. If we go for maximum sensitivity, you go to the top of this curve here and get more than 91 dB. But this is a very short coil, it's only around 8 millimeters. So if we want some more X max, we can go here and find another one. Like here we have a 15 millimeter voice coil that gets us about 5 millimeter X max. We can see the QT is around 0.5, which may be good for a closed box design, but for a bass reflex we need a low QT. So let's go in and select another magnet. We can take the next here and try with that one. And now we got much higher SPL, and we have a nice low QT of 0.33. So we say this is okay. Maybe we should try and look at the linearity. This is the BLX curve, showing how BL varies with the voice coil traveling through the gap. It should be symmetric, and we can just quickly try and extend the pole piece, and now we got a very nice symmetric curve, and our design is done. However, if we want it shielded, we can press this button, and now we have a shielded design. All the dimensions of the voice coil are shown here, number of windings and everything, and here are the till small parameters predicted by the program. Thank you. Hello, this is Peter Larsen from Loudsoft. I'll give you a short introduction to the new FINEMotor 2012. It contains more than 18,000 pre-calculated finite element calculations. So let's start with this example. This is a ferrite motor which has a 7 millimeter hole in the pole piece. Maybe we should try to increase that to 8 millimeters, but now you can see that the pole piece is saturated, indicated by the red here. So that was not a good idea. Let's go back, and now let's try and look at the BLX curve, because you can see it's not very symmetrical. These two curves should overlap. And we can do something with the adjustments here. We have a number of options, so let me try to extend the pole piece first. It seems to work fine. Now I can use the mouse wheel and then fine-tune this here. So let's see how far we have to go. It's something around here, I guess. Yes, now it's fine. You can see the curve is very symmetrical now. 4.5 X max in each direction, and symmetric. So that's one good adjustment, and we can do even more than that. I have number 3 example here, which is actually the same thing. So that this time I want to play with the undercutting the pole piece at the same time, and what we want is to get close to a symmetric curve which is flat, which is what we have about now. You can see it's absolutely symmetric and it's very flat now. This is done by undercutting the pole piece here. You can see how much it is there. We can see that we have undercut the extension of the pole piece too, and the extension is by itself 3 millimeters. So fine details. Now we have optimized the BLX curve. Moving on to another example. In this case we have added, it's a smaller motor, we have added a back magnet to gain a little more sensitivity and have some better shielding. You can see in this example the QT is 0.55, which is a bit high. usable for a closed box application, we can actually fine-tune this again with using a number of magnets here. So with this magnet we actually have reduced the QT to 0.50. Moving on to another example, here is a ferrite motor for a tweeter, and you can see in this example it's heavily saturated. Both the pole piece and the top plate are saturated. Now I'll show you another kind of motor. This is an inside inside neodymium motor for a tweeter. It could have been ferrite as well. Let's take some of these out. I'll just turn them off for now. They are still there, but now we'll concentrate on this one here and then zoom in. In this case we have put on a top magnet here, and we want to optimize the size of this one. So first I can try and apply some undercut, and this looks maybe pretty suitable, and then I can try and do something about the thickness of the magnet, and I think maybe this will be fine because we have much better sensitivity now and very good VLX curve. So this is now an optimized motor with a top magnet. Finally, here's another example of a similar one where we have made the top plate 1.8 instead of 2, and now the top plate, or the pole plate rather, is saturated. All this you could have done in using higher precision, which is especially for micro speakers. So you can see now we have we have even 4 digits here, so we can work with real small numbers here. Thank you.